Hello viewers, welcome back to my SpeedMaths and Math Electrical for you. Today we are going to see how to find out the characteristic equation for 3x3 matrix. Before that previous video, most of the viewers asked for the practice question. So we have listed out few of the practice question for 2x2 matrix in which the questions and answers are given directly. This is a 2x2 matrix for which the characteristic equation is obtained for given this 2x2 matrix is given. So list of the 4 problems are also given. Along with that, the characteristic equation is given for the each and every 2x2 matrix, 3 matrix. Same characteristic equation is given A minus lambda I equal to 0. For a 3x3 matrix, let us see how to write the characteristic equation, in which it is given as lambda cube minus C1 lambda square C2 lambda minus C3 equal to 0. Let us see how to find out the value of C1, C2 and C3. So for a given A matrix, let us consider A, B, C in the first row, second row D, E, F, G, H and I. Usually a matrix is represented by A11, A12, A13 in the first row. Second row A21, A22 and A23. Third row A31, A32 and A33. How to find out C1 is just add the leading diagonal what we have shown with the PowerPoint now, A, E and I. Just the leading diagonal, and C2 is the leading diagonal. We have to find the sum of the minor of the main diagonal element, and C3 is usually the determinant of A. Let us see an example with the given matrix how to write C1, C2 and C3. Consider a matrix in which we have A, B, C, D, E, F in the first row and second row, and third row we have G, H and I. The same format we have written A11, A12, A13, A21, A22, A23, A31, A32 and A33. Now let us see, first we will have the leading diagonal AEF for your C1. So C1 is represented in which and straight arrow mark is given with the black dark line is given now. So you'll get A, E and I, that is nothing but A11, A22 and A33. Now we'll see how to find out C2, that is sum of the minor of the leading diagonal element. So in which A is A11, E is A22 and I is A33. For each of this element we'll see how to write the diagonal element minor value. So first row and the corresponding column will go. So remaining is E, F, H and I. Second one is A22, that is E value. The corresponding row and the corresponding column will go. Remaining is A, C, G and I. Similarly for I, the corresponding row and the corresponding column will go. So remaining is A, B, D and E. Then usual matrix we have to expand with procedure what you have it already, how to find the determinant. And C3 is nothing but the determinant of the matrix, either by expanding the first row or by expanding the second row, or expanding by the third row or expanding by the first column. Here the C3 is expand by using your matrix with first row expansion. When you take first row, we'll have A11. When you add A11, if it is or even value, then you have to indicate the first element as positive. Take the second element 1 and 2. So when 1 and 2 is added, it is an odd number. So the B element should be written as minus C. And A13, that is 1 and 3 it is 4, so it is an even number. So we have to write plus C. Now let us see how to write the determinant of this matrix for A, B and C by expanding the first row. When you expand the first element of A, the corresponding row and the corresponding column will go. So remaining is E, F, H and I. As already we discussed out why you are writing positive, negative and positive. Now for the element B, that is first row and the corresponding column will go. So remaining is D, F, G and I. Now third element, that is first row of the third element and the third column element value. So remaining is D, E, G and H. Then usual expansion we will write determinant A times of that expansion will write B times of that expansion and C times of that expansion. Once you know the value of C1, C2 and C3, we can substitute in the characteristic equation lambda cube minus C1 lambda square C2 lambda minus C3 equal to 0. Now let us pass on to see an example with numerical value how the eigenvalues for a 3x3 matrix is determined. Let us have a matrix 1, 0, minus 1, 1, 2 and 1, 2, 2 and 3. Now let us consider a matrix A 1, 0, minus 1, 1, 2 and 1, 2, 2 and 3. Now the characteristic equation for any order of the matrix, we can write the characteristic equation as A minus lambda I. This will be useful when you are going to find out the eigenvectors. In the upcoming videos, we will see why this characteristic equation is written like this. Now with the expansion of the same formula, lambda cube minus C1 lambda square, C2 lambda minus C3 equal to 0. C1 is the sum of the main leading diagonal element, that is 1, 2 and 3. So we have just added the element 1, 2 and 3 and then it is equal to 6. Then C2 is the minor of the leading diagonal element. So every element 1, 2 and 3 we have to find out the minor for this leading diagonal element. Let us see how to find out the leading diagonal element. So first we are going to find out for A11. So remaining element is 2, 1, 2 and 3. Next element is 2. That corresponding row and the corresponding column will go. So remaining is 1, minus 1, 2 and 3. Then third element is 3. That is remaining element is 1, 0, 1 and 2. With usual expansion determinant, we will explain you for the first element alone. Multiply this two element and then multiply this two element. With that we can able to find out and we can see the determinant for the remaining element also. Now let us see how to find out the value for the first element, that is 2 into 3 to 6, 6 minus 2, 3 into 1. 3 into 1, then minus of minus will become positive, so 2 into 1 it will become 2. The next one is 2 into 1, 1 minus 0 it is 1. So 6 minus 2 it is 4, 3 plus 2 it is 5, 2 minus 0 it is 2. So C2 is 11. Now let us see how to find out the determinant for your matrix A also by expanding the first row of the matrix. Make sure that always in any row or in any column, wherever the maximum 0 is there, we can expand with that, so that the element of this value multiplication will become 0 to the rest of the minor element value. Same matrix we have taken 1, 0, minus 1, 1, 2, 1, 2, 2, 3. So 1 times of first row and first column will go. Remaining is 2, 1, 2 and 3. Next 0 and anything is 0, but anyhow we have shown how what is the minor element for this 1, 1, 2 and 3. Then third one is minus, though it is positive we have to write negative element is given here, so we have to write negative element. Remaining is 1, 2 and 2, 2. We hope so everyone you understood how to find out the eigenvalues for C1, C2 and C3 for the given matrix A. Same procedure, 6 into 2 minus 2 into 1, 0 and anything is 0, 2 minus 4. Then 6 into 2 it is 4, outside value what you have written, we have written 0 and anything is going to be 0 here. 1 minus 2 is minus 2, so we written minus 2. Now just multiply this matrix row, that is this C3 value as it is 1 into 4 it is 4, negative will become positive and then we will get 2. So C3 equal to 0. Now we have calculated what is C1, we have calculated what is C2, we have calculated what is C3. Now we will just write all the three eigenvalues. In the next slide we will show the same PowerPoint in the next slide so that we can able to understand how we have written. So just to the same matrix we have written as it is, all the values are written here. What the calculation we have got in the previous slide we have written as it is. Now the matrix A is given. The characteristic equation for a 3x3 matrix is written, in which C1, C2 and C3 are written. We will substitute in your characteristic equation to this above one. So C1 is 6, C2 is 11 and C3 is 6. So we'll get lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0. So any 2 cross 2 order of the equation can be calculated directly, but 3 cross 3 third order equation cannot be calculated directly. So we have to use only the synthetic division. We'll just try to recollect how to use your synthetic division first, then we'll try to find out the remaining roots for this equation. So first put an L-shape format, write all the coefficients of lambda cube, lambda square, lambda and constant. So lambda cube coefficient is 1, lambda square coefficient is 6, lambda coefficient is 11 and the constant is minus 6. So you have to obtain 0 to this last element value, will take 1. Always we have to write 0 here. Multiply this 2 element and write the next value. Then multiply this 2 and write the value here and add this to 6, minus 6 and 1, so it is minus 5. Minus 5 and 1, once again we need to multiply, so you'll get minus 5, add this, you'll get 6. Then 6 into 1 it is 6. Put the same element and add this to, will get 0. So once you obtain 0, we can write the solution to this characteristic equation, that is lambda minus 1. Remaining is constant lambda, lambda square, multiply. So lambda square minus 5 lambda plus 6 equal to 0. Just factorize this equation. Already we know when you multiply you should get plus 6, addition we should get minus 5. So the factors are minus 2 and minus 3. So with this we can obtain the eigenvalues as by equating it to 0, lambda minus 1 equal to 0, lambda minus 2 equal to 0, lambda minus 3 equal to 0. So we'll obtain the eigenvalues as 1, 2 and 3. Thanks for watching everyone, and subscribe to my channel to get more update on all the matrix and electrical core papers also. Thanks for watching.